In some questions in section 4.1, you're going to be asked to describe a system without actually graphing it. So describe if it has intersections, is it parallel lines, overlapping lines, or whatever. So here's what you want to do in that case. Put both equations into the y equals mx plus b form. And then you're going to take a look and see what does the slope and the y-intercept look like for the two different equations. So if the two equations come out with equal slope, and remember again that's the m value, and equal intercept, and that's the y-intercept, and that's indicated by the b value, then it's going to look something like this. So I have equal slopes, and going through the same y-intercept means I must have two lines that overlap each other. Alright, so then you have infinitely many solutions. Infinite number of solutions. So that's one possibility. Another possibility is if you have equal slope again, but you do not have equal y-intercept, or you have different b values. That would be something like this. Right? They have the same steepness, but they're crossing the y-axis at different points. Parallel lines. No solution. Now this system up here, the equations would be called dependent equations. And down here it would be called inconsistent. And we still have a third possibility, which is, whoops, shoot, there you go. So equal slope, different b, you get parallel lines, meaning they don't intersect, you get no solution. Third possibility is that we have different slopes. And then it doesn't matter what the y-intercepts are. If you have different slopes, you just get two lines that intersect somewhere. You will get one solution. So it's neither inconsistent nor dependent. So let's look at some problems. Number 13 and 14 that use this idea. Number 13. Without graphing, describe the system. So let's put each one into y equals mx plus b form. If I have x take away y equals 2, then I can take away an x on both sides. That gives me minus y equals negative x plus 2. Multiply every term by a negative 1, which is like multiplying both sides of the equation by minus 1. That clears away the minus in front of the y, and we get y equals x take away 2. So that's our first equation. The other one we're comparing it to is 7x equals 7y plus 6. So let's go ahead and solve for it in y equals mx plus b form. So if I take away 6 on both sides, so I want to isolate the y. Taking away 6 on both sides, I get 7x minus 6 equals 7y. Divide each term by 7. It cancels out. I get x minus 6 over 7 equals y. And that is in the correct form, but usually we see it with the y on the left side, so just move that piece over and say y equals x take away 6 over 7. Alright, and then when we're comparing it to y equals x minus 2, let's look at the slopes. Both slopes are 1. Equal slopes. Alright, so that means either we have a line, two lines sitting on top of each other, or we have parallel lines, depending on the intercepts. The intercepts are different. They're different b values. Therefore, we have parallel lines. Which means we have no solution. And we have an inconsistent system. So that would be the description of our system. And let's see if we can fit one more in here. Number 14. So again, let's solve the y equals mx plus b form because we want to describe our system. X take away y equals 8. Taking away x on both sides, we get minus y equals negative x plus 8. Multiplying each term by minus 1. Y equals x, take away 8. And the other one, take away 26 on both sides. We want to clear everything away from the y. So that gives us 4x minus 26 equals 7y. And then we want to divide everybody by, or each term by 7. So that gives us 4/7 x minus 26 over 7 equals y. And let's put it in the way we're used to seeing it, which is y on the left side. So y equals 4/7 x, take away 26 over 7, and the one we're comparing it to is y equals x minus 8. These have different slopes. This one has slope 4/7, this one has slope 1. Therefore, what we have is a case of two lines that are intersecting together. And they intersect at one point. So we have one solution. And it's neither a dependent or an inconsistent system.